Hi, I'm Steve Wong with VMware. Steve Wong with VMware, software engineer. I've been a contributor to Kubernetes storage since 2015. So I'm going to start this. It's a little weird. I'm not going to go here telling you really about VMware product. One of the things about VMware, I assume everybody in the room knows who VMware is. We really are in a position where we don't have one thing to promote. At this point, we've got Kubernetes, several distributions, and frankly, we can probably support running most of what's on this sponsored list on top of vSphere. If we'd like to see you use our stack to have one throat to choke with both our hypervisor and our software-defined networking, but if you choose to cherry pick individual solutions, we'd be happy to support you. We run in major public clouds as well as on-prem. I borrowed this concept from Chris Meller of the Register, one of my favorite things to read, but he came up with this idea of the storage classification stack, and I think it's important because this is complex and it builds from the bottom of the physical storage implementation to the interfaces to things that are essentially software running on top of this. If you're on a public cloud or you're buying appliances, below this line you don't get to choose, but they're still in play and you need to think about them. So it's things about whether the devices are SATA, SAS, NVMe, the interfaces, because these things affect your operation. Even storage ultimately connects on networking unless it's DAS, and they affect what kind of result you get when you deploy Kubernetes in a cloud. So I'm going to go over some considerations when you choose your technology. Number one, do you need cloud nativeness in the sense of portability? I suspect for all of you in this room, if you came here, the answer is yes. But what this means is what you'd like is deploy stateless and stateful applications that can't even tell where they're running and are just going to work regardless. So this really comes down to the three modes in that Meller chart of block, object store, and file. And I would contend that when you're consuming block storage, the kind of things used traditionally by transactional SQL databases, but other apps as well, Kubernetes already provides an abstraction layer, so that's largely going to be portable. You can run another layer on top of that that makes it double portable, but there might be such a thing as too many abstraction layers. So it's almost hard not to get portability these days with CSI and the storage plugins of Kubernetes, assuming you're on Kubernetes. For object store, I think the battle has been won, and I would contend that for object store, the S3 API is a near de facto standard everywhere. It's like every public cloud in the world has elected to provide an S3 compatible API, and vendors who do object stores on-prem are forced by the marketplace to deliver S3 API. Therefore, you shouldn't have unless you're stupid and use some other API to get to your object store, you should be portable. File is the one area that maybe is not so portable. NFS, SMB, Amazon EFS are all standards, but some of these are going to lock you into something. I can't give you a magic solution to that other than evaluate whether you really need to use a file store interface, and if you do, maybe large numbers of those apps are legacy anyway. Often cloud nativeness is also this concept of elastic scalability, that I don't want to go out there day one and be able to 100% predict my needs and not pay as I grow. With public clouds, this should be easy, that what you're buying is scalable. When you're on-prem, you can buy hardware appliances, but they generally scale across a range, and you need to pigeonhole about where you're going to go. They might scale over a range of 1,000 to 1, but they don't go 10 million to 1. With software defined, maybe you can contend that that's easier to put a layer there to allow you that elastic scalability. But what you have to ask when you come up with a solution that purports to be scalable is, look at the technology and ask yourself, will the network bandwidth grow as I grow capacity? Because typically you need that. But there are some technologies that put a head unit on there with a fixed amount of bandwidth from day one, and you throw capacity over it over the course of 2 or 3 years, and network's not growing with it, and you might be in trouble. Likewise, for software defined, they often use CPU utilization, and if you go with something like a hyperconverged, and this can even apply to VMware's own products, you might have a fixed ratio of CPU cores to the amount of storage you can mount there. If you can't predict that over time, and you might get yourself in trouble. So it's just something to consider. Number 3, does your storage also need to support non-containerized workloads? By that I mean, yeah, it's great, greenfield, going into containers, horizontally scalable, it's the new world, it's cloud-native apps, but you might have VMs. Some of these storage solutions were built in a VMware, in a VM era, and can easily and obviously support VMs. And my contention is that things like CSI and Kubernetes storage plugins let you simultaneously support both. You have to look at your own workload. If you're 100% container, maybe this doesn't apply to you, but if you've got this legacy mix, maybe even some bare metal mixed in and that isn't even VM, you may want to have one unified storage solution that can simultaneously host up storage for all of this. There's another issue here of, if you have an existing one, sticking with what you know might be lower risk unless the old way just doesn't meet your requirements. Finally, things to ask are, how are day 2 things like capacity expansion and updates handled? You know, I've been to a lot of sessions where they paint this glowing picture of, look how easy it is to deploy this little mini cluster in 5 minutes. And, you know, they're not looking at any failure scenarios or faults. And often the day 2 is where you're going to live the rest of your life, not that initial install. You're going to do that once, and then you're going to be faced with what it's like to live like long term. It's like bringing home that puppy where it's great, but you're going to have to pay for vet bills and feeding it over a number of years. Finally, consider network demands. I don't know, am I out of time?
Yes.
Yeah, okay. I'll respect the time.
Thank you so much. Thank you, Stephen, and thank you to everybody.